Welcome and thanks for joining me today. Before diving into the configuration of the AWS Web Application Firewall, don't forget to hit on like and subscribe below so you won't miss out on my future content. Today, I'm exploring the AWS WAF, a powerful tool for safeguarding web applications. By defining rules to allow, block, or monitor web requests, the WAF provides essential protection against application layer attacks that can compromise security and availability. Plus, when coupled with other services, the WAF is also a key player in incident response. It is a great tool as part of a defense in depth strategy and improving your security posture. So without any further delay, let's jump into the AWS console and check out this WAF. And we are at the AWS Management Console. We are logged in and ready to go. In this demonstration, I will show how I was able to use the AWS Web Application Firewall to block unwanted web traffic to 2 load balance web servers that are part of my deployment. So to begin, I will first need to create a security group for the load balancer that is part of this deployment. From the EC2 console, I can navigate to security group. We see that there is a default VPC security group, but we'll go ahead and create a new one that will be used specifically for this demonstration. First things first, we'll go ahead and give the security group a name. I'll go ahead and call this one Load Balancer. If I can type -SG, we'll go ahead and give it a description. Security group for the load balancer. Next, we're going to just go ahead and select the default VPC. Not ideal in a production environment, but it'll suit our needs for this demonstration. We're going to go ahead and create a couple of inbound rules here. We have the HTTP protocol, TCP, port range 80, and we're going to go ahead and select a custom source, the quad 0.0.0.0/0. We're going to go ahead and create that security group, and that looks like that has deployed successfully. Look at the details, inbound rule, success. I'm going to go ahead and give this inbound rule a name just to kind of make my notes look a little nicer. But here we can see details about the rule below if we want to verify that that has been configured as intended. I'll go ahead and give it a name. I'll just give it a little nickname of allow HTTP, and I'll go ahead and click on save. And we're looking good with our security group. In the next step, I will go ahead and deploy the 2 web servers in our US East North Virginia region. We can navigate to instances on the left panel and click on Launch Instance. We're going to go ahead and give our web server a name. I'll name the first one Web Server -A. And we will scroll down and we're going to choose the application and OS image that we would like from the marketplace, and we're going to go ahead and go with the Amazon Machine Image, AMI. Search for Amazon Linux 2 AMI in the search box and click on select. I'm going to go with the T4G Nano. If you still have a free tier option available, you can save money by utilizing a T2 Micro or a T3 Micro. Unfortunately, I no longer have the free tier option available. Next up, we'll go ahead and create a key pair that will be used for authenticating our connection request to our instance to ensure security. We'll go ahead and call that WAF LB key. You can kind of name it whatever you'd like. And then the next step, we need to modify some network settings. First off, we want to ensure that we enable the auto assign for public IP. And then next, we'll go ahead and create a security group for the web servers. We're going to go ahead and keep the default VPC. And for this creation of the security group, I'm going to go ahead and give it a name. I'm going to name it web server-sg. And you can choose to name your security group whatever it is you'd like to name it, so long as you are in compliance with the naming guidelines that are listed here. I'm going to go ahead and type in a description. It says required security group for the web server. As far as inbound security group rules, I can see that the SSH protocol over TCP port 22 has already been enabled by default. I'm going to go ahead and allow any HTTP traffic over TCP port 80. We're going to choose a custom source type because we're going to actually restrict this to a source, any source that has been defined as allowed by the load balancer security group. So we're going to go ahead and type in load balancer security group and select that option. And this looks good for our security group rules. We have our SSH over TCP 22, anywhere, any IP address sourced from anywhere. And next, finally, we need to configure some advanced details in the user data section. I have an HTML page that I would like to have served up by the Apache HTTPD web server. This one will allow us to determine when our request is being load balanced to web server A, and that one's going to show up with a red background, and we'll get a message broadcasted to the screen indicating we are receiving the response from web server A. So we're going to go ahead and launch this instance now. This looks good. Yes, it's going to take a little while for that to complete. There we go. Success. The launch has been successfully initiated. It will still take a little bit of time for it to fully be available. But what we'll do is while we're waiting on that, we're going to go ahead and launch web server B. So here we can see that the status check indicates that it is initializing. I can see the public IP address of web server A, security group, WAF LB key, launch time, and this all looks great. So it's going to take a couple of minutes for web server A to become available. We'll go ahead and launch web server B while we're waiting. So we'll go ahead and give web server B a name, exactly that, web server -B, pretty much repeating the same process as what was completed for web server A. Just doing the same for web server B at this point. And we're going to select the AMI Linux 2 image. I'm going to go ahead with the same instance type, t4g.nano. I'm going to select the existing key pair that was deployed for my server A. And of course, we need the auto assign public IP enable. I'm going to edit the network settings, stick with the default VPC, but I need to select my existing security group that was created for the web server in the previous web server A. So we're going to apply that same one to web server B. And then finally, we can scroll down and deal with the user data section in the advanced details section. And I'm going to paste in a script that is going to be used to deploy an HTML web page during the creation process for the web server B. Go ahead and I will paste that in. And that looks good. We will see a display in light blue in the event that our request is being forwarded to web server B by the load balancer that will sit behind the web application firewall. And this looks good. So web server B is now in the process of being created. I'll go ahead and refresh, and I can see that both web servers are still in the initializing state as far as the status check is concerned, but that's okay. We'll go ahead and it went ahead and changed to a running state. We'll go ahead and move forward with the next step. And in our next step, we need to add our web server A and web server B to the target groups that will be used with our load balancer. So I'm going to scroll down on the left panel to target groups and select, and I can go ahead and click on create target group. And when we specify the group details, we're going to choose to use instances as our backend pool of resources that will be used for with the load balancer. So I'm going to go ahead and give the target group a name, and we're going to call it web-server-tg. Sounds like a good name that fits well. We're going to go ahead with keeping most of our settings default, but we'll keep the health check protocol at HTTP. That's port 80. That looks good. We're going to go with an IP address type of IPv4. We're going to utilize the default VPC. Works fine for our particular scenario. And we have our HTTP for our health check protocol. And for our health check path, I guess we can go ahead and modify. We're going to go ahead and choose the health check path with /index.html. So this matches the web page that is created that will be served up by the web servers, the Apache web servers. So we're going to go ahead and click on next. And we're going to register those targets. We have both targets listed here, available instances. We have web server A and we have web server B. We're going to go ahead and include them as pending below. Go ahead and scroll down. Our targets are selected to be included as pending. We'll go ahead and click on Create Target Group. That looks good. And in our next step, we will need to create the load balancer. So we're going to go ahead and navigate to load balancers. And here we have the option to, let me get this out of the way, click on Create Load Balancer. And as you can see, we have a variety of different types of load balancers to choose from within AWS, just depending on what type of needs need to be met for our deployment. We are dealing with our web service here, so we're dealing with something that needs application level load balancing. We'll go ahead and choose this option. Here are some details. We'll go ahead and click on Create. And first up, we're going to go ahead and give our load balancer a name. Web-server-LB. I guess that sounds okay. The scheme that we're using is an internet-facing load balancer. For the network mapping, we're going to go ahead and leave the default VPC. That works fine for our scenario. This is a production environment. And here we're going to go ahead and select every availability zone that is available within the region where we have deployed our load balancers and soon our web application firewall. Next up, we want to modify our security groups. We're going to go ahead and remove this default security group. And we want to select the load balancer security group from the drop-down that we have previously created. Go ahead and remove the default. That helps us with allowing the type of traffic that we defined in that particular security group. Next, we will scroll down to the listener section. The listener is indicated that is using protocol HTTP and port 80, and that looks good. So for the listener, we have our target group that needs to be selected from the drop-down list here. And we see that we have available our web server TG target group, which is our web server A and our web server B that have been added to this group as part of our backend pool to be utilized as resources behind the load balancer. So we can go ahead and leave the tags. I'll leave them empty for the purposes of this lab. We can check out the summary here, and we can click on Create a load balancer. Now, it does take a few minutes for the load balancer to deploy. But as soon as that status moves to an active state, we can then begin testing the load balancer because it'll be ready to respond to any requests for requesting web traffic to the backend web servers. And we are now in an active state. Looks like we have our VPC settings, we have all of our availability zones, we have our listeners, we have our rules, we are forwarding traffic to web server TG target group, and we have one rule. So I'm going to go ahead and drill into the details here so I can get the FQDN, or the IP address of the web server, not the web server, but the load balancer front end. That way we can test out our load balancer. See, our targets are here, and these are looking good. So I'm going to go ahead and, where is it? Grab the DNS name here, which is the FQDN, the fully qualified domain name for the front end web server, front end load balancer. I'm going to paste that in, and I can see that my request is being responded to by web server A. I'm going to go ahead and click on refresh. I can see that now. The load balancer has sent that to B, A, B, A, B, A. So utilizing that one IP address or one shared fully qualified domain name, the load balancer is routing that traffic as expected and balancing that traffic, alternating between web server A and web server B. So long as those will remain in a healthy state, that is doing the job that it is expected to do. And in our next task, we will begin with configuring some critical components for the web application firewall. We will navigate to Security, Identity, and Compliance and scroll down to the WAF and Shield option located here under the Services menu. The Web ACL, Web Access Control List. Now, the Web Access Control List is going to allow us to define rules to manage the HTTP web requests that we receive inbound to our AWS resources that they will respond to. However, we must first identify what will be considered what we call interesting traffic that these rules need to be applied to. So it's very important that we pinpoint what will qualify as noteworthy traffic, and this is where creating the IP set will come into play. So we will begin that process by first creating an IP set. Go ahead and click on the Create IP Set button. And I'm going to go ahead and give this IP set a name. I'll go ahead and put my name in it because I'm actually going to include my own public IP address so that I will be restricted from access to reaching those web servers over their public IP address over the internet. So I'll go ahead and give it a name. We'll go ahead and give it a description. It says it's optional, but I'll go ahead and put one anyway. We're going to go ahead and deploy this into the US East North Virginia region. I will go with IP version IPv4. Let me get my public IP address. What is my IP.com? And I will grab that IP address, paste it in, and click on Create IP Set. Things look good. We're at the final stretch. We need to attach our IP set to our web ACL. So we'll go ahead and fill in those details for the web ACL to have it block my public IP address. So that way I won't be able to reach my back-end web servers that are sitting behind the application load balancer in my deployment. We'll go ahead. Up next, we will create the rule that will define the pattern to look for in web requests and the action that we desire to take when a request matches the pattern, that pattern being my public IP address as the source IP address. And that was created previously as Nisha IP set. So we'll go ahead and name the rule Nisha WAF rule. Using my source IP, action taken is to block. And we'll go ahead and click on Add Rule. Click on Next. We only have one rule, so we'll go ahead and select that rule and click on Next for the priority. I'll keep the defaults for the CloudWatch metrics option, and I'll go ahead and kick off the creation of this web ACL. So it's going to take a couple of minutes for this to spin up. And we're looking good. So now it is time to test out the working of the web application firewall. I'm going to navigate back to the DNS name of the front end load balancer, and we can see that we're presented with the error message of 403 forbidden. We are restricted access to the backend web servers based on the rules that we defined when we created the web application firewall web ACLs. So I'm going to now unblock the IP by navigating back to the IP sets, and I'm going to select my public IP address and go ahead and click on delete. And once we have allowed that a couple of minutes to kind of propagate or have that change take effect, we'll go ahead and retest whether or not I'm able to resume my access to those backend web servers by connecting through the front end load balancers. So here at the IP set, I'm going to go ahead and find my IP address. Here I have it set under the IP set name Misha IP set. I'm going to go ahead and select that, and I'm going to select my IP address. I'm going to click on delete. I'm going to confirm that deletion by typing delete in the field. Well, copy paste because I'm too lazy to type it. Click on delete. That was deleted successfully, was updated. So I'm going to go ahead and allow that a couple of minutes, and then we'll go ahead and retest. And here we can see that our reachability to the web servers has resumed after removal of the IP address of my IP address as the source IP address that was used as part of the blocking rules that were configured on the WAF, the web ACL of the WAF. We are receiving responses from server A and from server B as expected, and this actually completes the demonstration of how we can utilize the web application firewall in AWS to help us with inspecting and filtering incoming web traffic by applying a set of predefined rules that allow us to block, allow, or filter traffic based on criteria that we've defined. And this is a very helpful tool for protecting our web applications. I hope this demonstration has been helpful for you. Don't forget to hit like and subscribe below so you won't miss out on my future content. See you later.